Thank you. Okay, magdi-discuss ako tungkol sa third module natin entitled Case of Factors that Affect Potential and Kinetic Energy. Okay, so this is our topic for today. So in this module, we will be able to identify and explain the factors that affect potential and kinetic energy. Okay, identify and explain the factors that affect potential and kinetic energy. Okay, specifically, let us define gravitational gravitational potential energy and elastic energy. Number two, determine the factors. The factors that affect gravitational and potential energy gained by an object. Okay, GPE means gravitational potential energy. Number three is to calculate potential energy of an object. So number four, define kinetic energy. For number five, determine the factors that affect kinetic energy of an object. KE means kinetic energy. Number six is to calculate the kinetic energy of an object. Number seven is differentiate between gravitational potential energy and kinetic energy. And lastly, define and calculate work. Okay, so tapos na po. We've gained the scientific understanding of how rockets work. Okay, so now aerospace engineers use their understanding, okay, to make rockets. So rockets fly farther, so faster, higher, and more accurately. So our understanding of how rockets work arises. Okay, from Isaac Newton.
Yes po, sir.
Yes po,
Okay,
sir.
thank you. So from Isaac Newton's three laws of motion. Okay, so it is important for engineers to understand Newton's law. Okay, because they not only describe how rockets work, they also explain how everything, okay, that moves is at rest or at rest works. Okay, so the first question is which of Newton's three laws of motion applies to the flight of the rocket? Which of Newton's law of motion applies to the flight of the rocket? Okay, so the next question is what what would likely happen if air is released in this setup as seen in the illustration? So this is our illustration or drawing. Let's say you are holding this part, then you suddenly release the air. The question is what would likely happen if you release? That is the second question. Third question is which of Newton's three law? Okay, for number three is which of Newton's three laws of motion applies to the balloon rocket? Parehas siya naman ito. Okay, for number four is according to Newton's three laws, or according to Newton's third law pala, third law. How do you know that the action and reaction of forces on the balloon are equal? And lastly is what if the balloon is filled also with water? Will it move slower or faster? And then of course, why? Okay, so let us start. We use energy to do work. So this energy is defined as the ability to do work. So a system that processes energy has capability to do work or another. So energy is expressed in joules, or energy is like work, is also a scalar quantity. So there are many forms of energy. We have the first one, mechanical. Next is heat. Next is light. Number four is the chemical energy. Okay, we will focus on mechanical energy while as we discuss about energy and work. We'll also discuss work in relation to potential energy. So how do we define work? Who wants to define work? If we are going to define work, this is a task that we must tend to do, or we must do. Who wants to give another definition of work? Some may call work as working or doing an assignment, diba? Or sometimes work is called when you are when you are earning money. Let's say your parents are working, di ba? We call it sometimes or generally work. You're doing something and that is simply work. We generally define work as doing something. Diba? Parang kahit ano pa yan. Let's say you're asked to clean the house. Do something inside the house and that is commonly work. Next is you have work wherein you're finishing your assignments. In physics, we define work, and this is accompanied by change in energy, which is tama yung sinabi ni Jenica na kung saan what is done when a force is applied to move an object some distance. So the unit of work is joule. In physics, work is an abstract idea. So parang mahirap isipin na yung palang definition ng work in physics sa science. Okay? When work is done, it is accompanied by the change in energy. Okay na po ba?
Yes po, sir.
How about yung iba?
Okay na po, sir.
Okay na po, sir.
Okay. Saglit. Okay, buburahin ko na po ito. Narinig po ba ako? So how do we calculate work? So work is done when the force is applied, which is TF, applied to the object. So work is done, okay, when the force is applied to the object. It causes the object to move. Okay, to have a displacement. So pag sinabi nating displacement, ito yung trinabel ng isang object when the object is moved from one place to another in the same direction as the force applied. Displacement, the unit we use for displacement is D. Okay, so the symbol for work is capital W. So work is done when the force F is applied, okay, to the object. Okay, so to the object that causes the object to move. Okay, so in the same direction of the force applied. So the work done by a force can be calculated as W is equals to the product of F and T, which is force and displacement. Okay, thank you. This is work. How we're going to get work or calculate work is to multiply or get the product of these two variables, force and displacement, or sometimes it is called as distance. Okay, so the unit joule, which is or J, is named after the English physicist James Prescott. Okay, so the unit work for joule or the unit joule is named after the English physicist named James Prescott Joule. Okay, so this is also unit of energy. So we can use the joule, this one, for energy. Okay, 1 joule is equal to the work done or energy, or so 1 joule is equals to energy or work done. Okay, so expended in applying a force of 1 Newton through the distance of 1 meter. So let us have first a sample problem. So I'm going to erase this. Then let us answer or calculate simple problems. Okay, so let's have the formula for work. Let us have the problem first. A woman is pushing a grocery cart with 500 Newton force. So we already identify what is the value of F or the force, this one, along 7 meters. And 7 meters is distance or displacement, aisle. Okay, so nasa gitna sila. So how much work is done in pushing the cart from one end of aisle to another? Let us replace the variable with numbers. Okay, so we have 500 Newton for force. Then distance of 7 meters. Thank you. What are we going to do with these two numbers? Sabi natin is to get the product. When we say product, diba, it is pertaining to multiplication. When we say product, let's have 500 multiplied to 7. Let us see. So the work, 3,500. Ano po ba ang unit ng work? We only have to know the unit for work. Christy Jane na lang. Ay, tama. Si Christy Jane nagtataas ng kamay. Christy Jane?
Sir, I think joule.
Joule. Okay, thank you. So let us define gravitational energy. Gravitational energy is, let's say, gravitational potential energy is the energy stored in an object due to its position above the Earth's surface. So the formula for gravitational potential energy is PE mgh. Going to solve the potential energy, or we can say gravitational potential energy. Let us have this first. PE means potential energy. mgh is unknown for now. Where M is for mass, and the G is gravity. Let's have a problem, sample problem for gravitational potential energy. Okay, using this solution, the problem is a 0.1, not 0.1, 1 kilogram book is lifted 0.5 meters, okay, from the table, but the tabletop is 1 meter above the floor. So the force exerted in lifting the book is equal to its weight. What is the gravitational potential energy, GPE, of the book if the reference level were the floor? Okay, so paano natin sasagutin yan? With the use of this formula, which is the potential energy, we'll get the mass here, which is 1 kilogram. The gravity is standard, which is 9.8 meter per second square. Okay, standard yan. Kahit hindi makita yan sa problem, kahit saang problem, laging ganyan yung number niya, which is 9.8 meter per second square. The height is, the reference natin is the 1.5 meters. Bakit kaya ginamit yung 1.5? Kasi we have 0.5 here as the height. Okay, so kasi book is lifted 0.5 meter from the table. But the tabletop is 1 meter. Okay, so pinagsalo natin yan. Okay, from tabletop, tuktok nito, ang table, which is 1 meter, and then 0.5 as the book was lifted. So, ang tanong kasi is, if the reference level were the floor, kaya pinagsalo tong dalawang ito. Nakakasunod po ba?
Opo.
Yes po, sir.
If the reference level were not the floor, and we'll be using only the tabletop as the reference, okay, we'll have this height 0.5. Okay, kasi tabletop yung reference. Okay, nasusundan po ba? Pag sinabi kasi ng tabletop, which is yung pinaka ibabaw ng table. Kasi sabi sa dulo, what is a GPE or gravitational potential energy if the reference level were the floor? So meaning, pinaka sahig yung reference. Dun ka magsisimula. Tabletop, from floor, and then the tabletop would be 1, and then 0.5 meter, the book is lift or was lifted, pinagsalo natin. Okay? Wala lang pala sa taas. I have question. What is the potential, gravitational potential energy of the book if the reference level were the floor? We have the mass here, which is this one, 1 kilogram. Malalaman naman natin yan kung mass yun. Kasi kilogram. Okay? Next is the gravity, which is the standard 9.8 meter per second square. The height of 1.5 meters. Bakit naging 1.5, sir? Kasi 0.5 meter, the book is was lifted. And then the 1 meter is the distance of tabletop and then the floor. Okay, kinumbine natin yan, inad natin. So the solution would be using this formula. PE is equals to mgh. We'll be replacing those variables with numbers. 1 kg multiplied by 9.8 meter per second square and then 1.5 as the height. So, paano po gagawin natin? We will be multiplying these three numbers. Okay? Let us see. So, lang po yung calculator. We have 1 times 9.8 meter per second square, which is gravity, and then times 1.5. So, we'll be getting 14.7 joule. Sir, bakit J? Kasi nga, potential energy. Sir, paano pag kinetic? We'll have the same unit. Naintindihan po ba?
Yes po.
Okay. Tutuloy na lang natin to next time or next Monday kasi kulang tayo ng oras. Okay?